Imagine standing in a field in the middle of the day, and suddenly the sun vanishes. Or looking up at night to see a full moon turn the color of copper. For most of human history, these moments were terrifying. But these events are the result of precise mathematical alignments. By the end of this video, you will know exactly how this clockwork operates and exactly when to look up for the spectacular solar and lunar eclipses coming in 2026 and 2027. The mechanics come down to three objects: the sun, the earth, and the moon. All three are in constant, predictable motion. This diagram shows the basic geometry of an eclipse. It happens when these three celestial bodies form a perfectly straight line, allowing one to cast its shadow directly onto another. Which brings up an obvious question. The moon completes a full orbit around the Earth every single month. We have a new moon and a full moon every 29.5 days. So why don't we see a solar and lunar eclipse every single month? If the solar system looked exactly like the flat diagram we just saw, we would. The absence of monthly eclipses proves that our standard two-dimensional mental model of the solar system is missing a crucial geometric variable. This diagram shows what we're usually missing. The moon's orbital plane is tilted by about 5 degrees relative to the Earth's. Because of that tilt, its shadow usually passes into empty space. However, there are exactly two intersection points where the planes cross, called nodes. An eclipse becomes geometrically possible only when a full moon or new moon perfectly coincides with the moon crossing one of those specific nodes. That tiny 5-degree mathematical anomaly transforms these alignments into rare, highly anticipated spectacles. When that perfect alignment does happen during a full moon, Earth sits perfectly between the sun and the moon, casting its shadow outward. This is a lunar eclipse. But if the Earth is blocking the sun's light, you might expect the moon to go pitch black. Instead, during a total lunar eclipse, it often turns a vibrant copper red. This color shift is caused by a principle in optical physics called Rayleigh scattering. This diagram shows Earth's atmosphere acting like a giant lens. As sunlight hits the atmosphere, gases scatter the shorter blue wavelengths outward into space. The longer red light waves pass through and bend inward, projecting straight onto the lunar surface. This diagram shows the three different ways we experience the shadow. If the moon passes through the deepest shadow, it's a total lunar eclipse. If it only grazes the deep shadow, it's a partial eclipse. Passing through the faint outer edges creates a penumbral eclipse. This crimson glow is the combined light of every simultaneous sunrise and sunset on Earth, projected onto the lunar surface like a single cosmic canvas. A solar eclipse flips the script. This happens when the moon passes exactly between the sun and Earth. As it does, it casts two distinct shadows onto our planet's surface: the dark inner shadow, called the umbra, and the fainter outer shadow, called the penumbra. This diagram shows how the moon's distance from Earth creates different phenomena. Because its orbit is slightly elliptical, a farther moon appears smaller, leaving a bright ring of fire visible, an annular eclipse. When closer, it completely blocks the sun, creating a total eclipse. Observing these specific solar alignments carries extreme optical danger. The concentrated solar radiation can cause permanent eye damage in seconds. You must use ISO 12312-2 certified solar viewers. This is a specific international safety standard for specialized filters. Regular sunglasses, binoculars, and unprotected telescopes offer no protection against this level of light. These safety glasses are required for viewing all partial and annular phases of the eclipse. They can only be briefly removed during the exact moments of 100% totality, when the sun's face is completely blocked. While lunar eclipses are safe, a solar eclipse focuses intense radiation, causing instant ocular damage, making specialized filters strictly required. Because these orbital mechanics are driven by the exact sciences of gravity and geometry, we can map out these alignments centuries in advance. Based on NASA data, the next major lunar eclipses are coming soon. A total lunar eclipse will occur on March 3, 2026, followed by a partial lunar eclipse on August 27th and 28th of the same year. For solar eclipses, prepare for a total eclipse on August 12, 2026, and an annular eclipse on February 6, 2027. Take time now to acquire your ISO-certified glasses and mark these specific dates on your calendar. Every eclipse is a reminder that we live within a vast, perfectly timed clockwork system, operating with a precision that invites us to look up and truly understand our place in the cosmos.